Okay, let's start out by talking about exactly what a vector is, and then we'll come back to this problem. It's basically your first problem on my math lab. A vector has a starting point and an ending point. A vector travels from one point in the plane to another point in the plane. So for example, this one that I drew is going to travel from 1, 0 to 2, 7. It's a little off of scale, but that's okay. Vectors have components. This one, for example, at this point down here would be 2, 0. So you can see this vector moved 1 in the x direction and 7 in the y direction. And then if I wanted the length of the vector, I could use the Pythagorean theorem. This would be the square root of 1 plus 49, which is the square root of 50. Another way to do that is if I move from point to point, if I take the end point over here, which is the head, minus the tail over here, 2, 7 minus 1, 0, gives me the vector. This is what we use for vector notation, 1, 7. And then the magnitude of a vector, which has this notation, looks like absolute value. There's a reason, because you're finding length or distance, is the square root of the first term, the first component squared plus the second component squared, which is again the square root of 50, which we could break down to 5 square root 2. Okay, so every vector has a magnitude and a direction. You could also find the angle that goes with that direction. How would we go about finding this angle here? Oh, well, we are in trigonometry, right? So we could do the inverse tangent of 7 over 1. That would give us that angle right there. Okay. Good enough. Let's look at question number 1. So this basically has a picture with a couple of different vectors, and it asks us they ask us to find the magnitude of u and find the magnitude of v, and then describe whether u equals v. Well, the first thing you notice from the picture is that u and v are traveling in the same direction. So you can also figure that out if you go from head to tail. I do minus 3, minus 5, minus 3, minus 2. You can see this thing is minus 6, minus 3, and this vector down here is also minus 6, minus 3. These are the same vector, right? And their magnitude, if you find either one of them, is the square root of 36 plus 9, which is the square root of 45, which is 3 square root 5. So, yes, they have the same magnitude, and in fact, they are the same vector. Right? The thing about a vector, it has a magnitude and a direction, but you can move the position around. It is the same vector. Question 2 is very similar. Question 3 wants you to sketch a vector as a position vector and find its magnitude. So when it says as a position vector, it wants you to sketch it starting at the origin. And this is question 3. It says v equals 5i plus 3j. Well, something else for us to learn. This is equivalent to the notation that we had where we wrote 5, 3. Some definitions. I is the vector 1, 0, and j is the vector 0, 1. This is the unit vector pointing in the x direction, and this is the unit vector pointing in the y direction. So basically what this says is go 5 times I, which is 5 units out on x, and then 3 units up on y, which is the same thing that this says. It's 2 different ways of writing the same thing. So if I wanted to plot this vector, I would start here, put my tail here, go 5 units to the right, 3 units up, and draw my vector. Question 4 on MyMathLab has you take a point, -3, 4. It calls that the initial point, P1, and a terminal point, P2, which is 3, 2. So this vector goes from -3, -4 to 3, 2. And they want us to find, they want us to write this in terms of I and j. So we'll take this minus this minus this. So we're going to take 3, 2, basically minus 3 minus 4, which is going to give us 6, 6 as a vector. Basically that says, what did we do going from here to here? We went up 6, up 6. So this is the vector 6, 6. And that is 6i plus 6j, using our notation from the last problem. Now question 5 is asking us to do some operations with these. Gives us 2 vectors. We'll look at maybe the geometry of this a little more in a minute, but for right now, if it just wants a sum or a difference of these, you just do them component-wise. So if I want u minus v, I just do 8i minus 5i, that's 13i. -4j minus 9j is -13j. That's my vector uv. Or sorry, that's my vector u minus v. Question 7 gives me a vector v and asks me to find something called a unit vector in the direction of v. So note, v is a vector that points -24 to the left and 10 up. So basically this is a vector going something like this. They want us to find the unit vector, which means length 1, like our I and j vectors for length 1, that goes in that direction. So the way that you do this is you take this vector and you divide it by its length. So we have to find the magnitude of this vector. Well, the magnitude of the vector, you square this. So we're going to take -24, 10. I'd rather write it that way for right now. Although I guess they want it back in terms of I and j in the end. And then we're going to divide by the square root of 10 squared plus 24 squared. Well, it turns out that number on the bottom is, that number on the bottom is 26. So this is -24, 10 over 26. Well, if you divide each one of those terms, what you're left with is -12/13 I plus 5/13 j. Right, because 24 over 26 is 12/13, and 10 over 26 is 5/13. That's my vector that I need. Okay. Number 8 is the same. Question number 9. They tell us that the magnitude of v equals 16, and they tell us angle theta is 60 degrees. Again, this is question number 9. Well, if you think about it, this is just a trigonometry problem. I know theta is 60 degrees. I know the magnitude of my vector is 16. How am I going to get these values? Well, this one is going to be 16 sine 60, and this one's going to be 16 cosine of 60. So I get those numbers, and it's that much I plus that much j as my vectors. Not too bad. Okay, I think I have done enough of these that you have a pretty good start on what you need to do for the homework. So I'm going to stop the video here.